Throughout this course, we're going to be using the metric system of units, so I want to be sure that all of you are familiar with it. Probably you are already. I'm sure it gets taught at many stages of school, but we're going to go over it one more time just to make sure we're all on the same page. So here are the basic things that we want to measure in the metric system. Now, of course, these all have equivalent sorts of measures in other systems like the English system, but we're not going to care about those as much. We're going to really want to see you express all of these things in the metric system. So first of all, mass. The typical unit for mass in the metric system is the gram. What we're seeing here is a picture of about 1 gram of sugar in a teaspoon. So you can get an idea of roughly how much that is. For length, it's the meter. A meter is about the length of a guitar, so if you need to know about how long a meter is, it's also about the length of a yard. It's a little bit longer than a yard. The length of time in the metric system is the second, so it's not very long, but we're all familiar with seconds. And volume, of course, is the liter, and we're familiar with now liter bottles of drinks that we might take when we go out running or walking. All right, so these are the fundamental units that we're going to care about when we deal with the metric system. But it turns out that we're interested in a wide range of magnitudes of these different units. So we have prefixes in the metric system that allow us to adjust by factors of 10 the sizes and amounts that these things indicate. So here's a table of the various prefixes that are commonly used in the metric system, and I hope you will be glad to know that only the yellow ones are ones that we're going to use commonly, and I'll never ask you to memorize this. You can always look it up if you wish on your phone, but you're going to see and hear about kilo and centi and milli and nano and a little bit pico, so you will probably become familiar with those measurements no matter what. A kilo is 10 to the third, or 1,000 units, so a kilometer is 1,000 meters. A centimeter would be 1/100th of a meter, and we're familiar a little bit with centimeters. About 2.5 of those make an inch. A millimeter is 1/10 of a centimeter. And then two that you probably can't see with your eyes, unless you've got really good eyes, are nano and pico, which represent 1/100000th and 1/1000000000th of a unit of these things. So a nanogram would be 1/10000000th of a gram, and a picometer would be about the dimension of an atom, and it's about 1/1000000000th of a meter. Now, we also have compound units because we have things like velocity. Okay, velocity is distance traveled over time, and we simply use the metric system units for those two things combined together to make a unit of velocity in meters per second. For density, that's a measure of mass per unit volume, so we would use grams per liter, for example, in the metric system. We've already seen force, and it is essentially mass times acceleration, so it has units of kilograms times meters per second squared. Meters per second squared is a unit of acceleration. And we have already seen that that represents a newton in the metric system. Energy we've also seen as a compound unit, and it's force times distance, or kilogram meter squared per second squared, which we define as a joule, or use the capital J as the abbreviation for that. Now, one last thing, because we're dealing with big numbers, sometimes we still have big numbers even though we've used these prefixes in the metric system. So we want to get used to using scientific notation. Basically, all numbers are going to be written as one number A times 10 raised to another number B. Now, these two numbers have some strict constraints to them. A is always going to be a number between 1 and 10. Now, it can be positive or negative, but it's always going to be a magnitude that's between 1 and 10, less than 10. B can be anything, but it's always going to be an integer. And we call B the order of magnitude because it expresses in some ways how big that thing is. So, for example, if we want to compare a centimeter and a kilometer is going to be 10 to the third meters, whereas a centimeter is going to be 10 to the minus 2 meters. So that gives us a sense that a kilometer is much larger than a centimeter. Now, you're going to need to be able to convert things into this scientific notation. So let's look at a couple of examples. Let's suppose we have the number 367.23. What we do is we start at a position that's just to the right of the first non-zero unit here, and we count over to where the decimal point is, 1, 2. Well, that gives us the order of magnitude. It's going to be B is 2. So when we want to write this in scientific notation, we would shift the decimal point so that we're writing 3.6723. Now that is a number between 1 and 10, and it's raised to the 10 to the second power. That's the order of magnitude. Now we can also do this for numbers that are less than 1. So consider the number 0.000856. If we want to write this in scientific notation, we would start just to the right of the 8 and count over to the decimal point. 1, 2, 3, 4. So that tells us, since we counted to the left, that B is negative 4. So now when we write down the scientific notation for this, it's going to be 8.56 times 10 to the negative 4. All right, I hope you can see this pretty well. I'm going to give you here a little practice. So I want you to pause this video for just a second and see if you can answer this question and write this number that I've put on the board in scientific notation. All right, I hope you've had a chance to do that now, and you're now no longer paused in the video. So if we write that in scientific notation, we would find that it is 6.022 times 10 to the 23rd power. So it's a very large order of magnitude. And this is a special number in chemistry. It is equivalent to 1 mole. A mole is just the name for this number. It doesn't have any other significance. It's also called Avogadro's number. So I hope you've gotten a little bit of a feel for the metric system and scientific notation. We're going to be using them a lot this semester. One last thing, please don't forget to do your syllabus quiz, and you might want to do the review lesson 1A and complete the lesson quiz.